right. Let's get started with some more math today. Let's start with our warm-up. I'm going to give you guys a chance to pause the video and walk through these 4 problems that review what we talked about in our last lesson, how to solve one-step inequalities. All right. So I have some negatives here, but we're going to work this out. So if we'll redo number 1 over here. Let me get my pen. There we go. So negative 21 is less than k minus 8. So we come over here and go k is greater than. So we've got this answer. So we get rid of negative 8 by adding 8 to both sides. Ooh, I've got a negative here. Yay. Got to always practice those negatives. So if we are using this one, we're going to use keep. We can add. So we're actually subtracting because they're opposite signs. So we're going to say the answer is negative 13. So here's the one. That's why I put this as a warm-up. K is actually greater than negative 13. A lot of you guys have been writing it this way. So if we say negative 13, k is greater than. So you think about what the mouth's going to eat the bigger number. The bigger number is on the right-hand side this time. So if we do number 2, negative 3 is less than n minus 7. We're going to use positive 7 to get rid of negative 7. Again, another different signs, but this time we end up with a positive 4. So n is greater than positive 4. All the way, and then again, open circle on that one. Now take a look at our next one. How do we get rid of k in negative 7 is less than or equal to 1. So we're going to use a positive 7 to get rid of that. K is less than or equal to 8. So this time we're going to go close circle off to the left. And then we have a over 13 is less than or equal to 6. How do we get rid of it? We multiply it by 13. You're right. So we multiply it by 13, we get a is less than or equal to 78. So we have, again, our closed circle going towards the left. Glad you got all warmed up. Our brains are ready to go. Our juices are ready to go. Let's go ahead and move on to solving two-step inequalities. All right. So let's get started. Our goal today is that you can solve two-step inequalities using the order of operations in reverse to solve our problem. So one of the biggest things we want to look at is we reverse the order of operations. And we talked about this when we were doing this. When we simplify an expression, we work down. When we solve, we work in reverse. Because here we're trying to find a solution. Here we have a solution. We're trying to find the beginning. Okay? So let's take a look at how we work on this one. 2m is greater than 31. So again, lowest thing we look at any addition instruction. Yes, I've got 1 right here. I've got a positive 7. So how I clear a positive 7 is with a negative 7. So I have 2n is greater than, so 31 minus 7, we got 24. So we divide. Now we're going to go ahead and go multiply. Okay, multiply. How do I get rid of multiply? Its partner right here, it's division. So I'm going to divide both sides by 2. So n is greater than 12. And then you can see I've already got my number line right here. N is greater than 12. I've got to use an open circle, and I'm going to go this direction. All right. Let's have you give one a try. Pause the video and come up with this one. All right. Now let's take a look at this one. Now let's see if the tricky part on this one is not the solving, it's the graphing. So we're going to talk about this one. We did a few like this earlier, so hopefully you picked up on it. How do we get rid of negative 9? With a positive 9. So I'm going to get a negative 21 and 3x left. And how do I get rid of times 3? You guys are perfectly right. It's divided by 3. So I get negative 7 and x. So now here's the fun part. You have the right answer this way, but you got to think in terms of what's going on here. The mouth, going back to our elementary school years, the mouth eats the bigger number. It's always hungry. So where's the bigger number? It's x. So x is greater than negative 7. So it's going to be greater than negative 7. So greater than always goes right. Even though this is pointing to the left, it's because I actually have it going written backwards. The x is written second. Okay? All right, now I have a division problem in here. I had multiplication before. Now I've got a division problem. Well, let's take a look at how that changes everything. Well, I bet some of you are going, Mr. Maloney, you know what you did? You divided by 1. When I divide by 1, I really don't even have a division problem. You're right. I have a plus 2. Oh, don't need that bar underneath it. Don't need equal to. Oh, you guys are super astute and really quick on catching that. So we'd subtract 2 from both sides. You get a is less than 0. Oh, so anything less than 0, go in this direction. Now, let's just go ahead and practice this in case it was division, okay? So we'll put a 4 here. To be fair, that's not going to change the answer. So if we did the same thing we did over here. We'd subtract 2. But this time we're left with a divided by 4 is greater than 0. So if we multiply by 4 on both sides, that's how we cancel it. Again, we're trying to make that fraction look at like this, okay? So multiply 0 times 4, we still end up with that same answer we had a moment ago. It is your turn to try one. Now this one is not as easy. I didn't put a 1 on the bottom, but I did make it so that would work out pretty well. All right, good luck. All right, now we have m divided by 10 plus 7 is less than 6. So a number divided by 10 plus 7 is less than 6. So let's see how that works out. First thing we do is get rid of that positive 7 with a negative 7. Ooh, so we got more negatives. I love negatives. Helps me think more in depth about math. So now I've got a negative 1. How do I get rid of divided by 10? You guys are 100% right. It's times 10. Oh, now we got to remember our multiplication rules. So a negative times a negative is a positive. A positive times a positive is a positive, but a negative times a positive stays negative. So we're going to go have it as negative 10. So m is less than negative 10. Open circle, less than 10. Now, some of you might be going, Mr. Maloney, 12 is bigger than 10. But if you go back and think about our negatives, anything to the left is always smaller. So if you owe mom $10 or you owe mom $12, when you have less money, when you owe mom $12 than if you owe mom 10. Okay, now I've got a tricky problem here. I put a tricky one in here, one to catch you guys. So remember GEMDIS. Let me get rid of that P. I don't know what my brain was thinking. GEMDIS here. This has a little bit of a trick to it. It doesn't actually start here. It's going to start here. And here's the reason why. Anytime we have this line across an entire expression, it's giving you an implied parenthesis, saying, okay, there's really a set of parentheses around n minus 5 divided by 20. And it's going to say, do n minus 5 first, then divide by 20. So we'd be going parentheses, and then division. Well, if I'm going in reverse, I'm actually going to do n minus 5 over 20. I'm going to start by multiplying by 20, because order of operations says parentheses is the very last thing I'm going to do. So I multiply both sides by 20. So now I have negative 20 is greater than n minus 5. How do I get rid of a negative 5? Well, of course, you're right, with a positive 5. So negative 15 is greater than n. So let's see. So n is less. So now we got to read it from the n. What number would make this statement? The mouth is bigger. So this is going to be your biggest number at 15. If that's our biggest number, these are all smaller. So n is actually less than negative 15. All right, your turn to give this one a try. Pause the video and give it a shot. All right, I'm going to take a moment and rewrite it. All right, so we did. You guys are right. We start by multiplying by 10. So I get 10 and 7 plus n. And you're right, to get rid of our positive 7, we use a negative 7. And I'm going to get 3 is, and then, so n, not m, n. N is less than or equal to 3. So if we're going less than or equal to, it means 3 is going to be my biggest number. It's going to go this way. All right. Now we just got some more practice problems. Okay, so go ahead and pause the video and try this problem. See what you come up with. Oh, wait, I'm sorry. My mistake. I don't want you to pause the video. This is a trick problem, and we're going to have some fun with it. This is going to really extend your brain and make you think a little bit. So we start off here with negative 10a plus 3 is greater than or equal to negative 137. So you're telling me, Mr. Lloyd, this is just like all the other problems we did. It's actually not. It's really, really close, but it has a negative there. Oh, I didn't want to get rid of that. I wanted to highlight that. There we go. it's got a negative here. That negative's going to change some stuff. So let's see what we do. So the first thing we do, we still work our GEMDIS in reverse. Okay, so we're going to start by adding a -3 to both sides. So now I've got a -37 and a -3. So I've got -10a and -140 because I have same signs add. Now you're right to say we divide by -10. But here's where everything changes. Okay, so now I've got a left on this side. You're 100% correct. And if I divide -40 by -10, I get +14. Now, this is the part that's tricky. We're so used to thinking in terms of equal signs and equal signs not changing. What that negative does, if you think about it, every time we did a negative times a positive, what do we end up with? A negative. Okay? Or a negative times a negative, we end up with a positive. Okay? Well, if you'll notice, what we have here changes. It changes the other side of the equation. It makes it its opposite. If it starts with a positive and goes times a negative, anytime I multiply or divide by a negative, it actually does more than just change the sign of the operation. It has to change everything. That's the thing about math. To keep everything equal, I have to treat everything the same. And up until now, we really haven't had to think about the sign being something that had to be treated equal. We had to think about the equal sign, which couldn't turn around. It wouldn't change at all. It looks the same. It's symmetrical, forward, backwards, up, down, all the way. But if I take the opposite of this side and the opposite of this side, I can't just leave out my sign here in the middle. So I've got to take the opposite of the sign. So the A is actually less than 14 now. Less than or equal to 14. It's a tricky concept. I'm not going to have a lot of these, but I want you to think about it. Go ahead and try this one. See if you can solve this one on your own. All right, so you guys were right to say, okay, we started by adding 7. This time I have -4x is greater than or equal to 20. I'm going to divide by -4. So this is going to say x, and I'm going to flip my sign because I'm taking the opposite of everything. Negatives here to positive, greater than to less than, +20 to -5. So -5, less than, go in this direction. Okay. All right. Now it's time for you guys to work on your homework. You've got 12 problems. Go ahead and work through those. If you have questions, please come see me in the morning. I'll be happy to help. If not, good luck and have a great day.